Oh, there we go. So here's the equation. X plus y equals 4. So what I want you to do is tell me a value of x and y that works. What can I plug in that will work? 3 and 1, yeah. I only heard one answer, and it was actually didn't work. So another one. 2 and 2, 4 and 0. How about 0 and 4? Is that different than 4 and 0? Yeah, because when we write these down, these are called what? It's called a point, or coordinates, or an ordered pair. These round brackets in math actually mean or the order is important. If you list something in round brackets, you're saying it has to go in that order. And then there's other brackets, like these curly brackets. And if we put something in here, then the order doesn't matter. So the curly bracket, right, it's a set. So this is a set bracket, and sets, the order doesn't matter. So there's different types of brackets, and they mean different things. But these round brackets are ordered brackets, so it's saying whatever's listed in them, the order is important. X comes first, and then Y, always. 1, 3, we can write down. Is there any others? Thank you. Negative 1 and 5, or negative 5 and 1. How about something with a decimal? What if I put 0.5? What would the other one have to be? 3.5? We could do fractions. Now, could I spend the rest of the course just doing solutions to this question? Yes. We could do that forever and never do another thing. Every day come back and still keep listing them. Because how many solutions work in one linear equation? Infinite. So the solution, these are all called solutions to this equation. There are no restrictions on a linear equation, whereas if there was a fraction or a radical, those have restrictions. So you couldn't list certain points. But here we can pick any x value at all. If I picked 100, there is a matching y value for that. What would it be? Negative 96. Right? That also works. Right? No matter what x value I pick, you can tell a y value. Now, not all linear equations are that easy to get solutions for. So, say for example, I wrote down 2x minus 3y equals 6. Now, if I asked you to find solutions for that, can you do any in your head? Can you think of a number that works? No. What did you say? 1 and 1? No, because 1 would be 2 minus 3. It's negative 1, not 6. Can someone think of anything that works? It's not as easy, is it? 6 and 2, let's try it. So 2 times 6 minus 3 times 2 is 12 minus 6 is 6. So we got one. Good. There's lots, and they're still infinite, but they're not as easy to find. So how do we find the solutions for an equation that we can't just look at it and tell the points that work? We could make a table of values. We could, just like with these, I said you can pick any x value you want and then find the coordinating y value. You could do the same thing here. So we could say, okay, well, if x is 6, then what did I do? You can plug in the x is 6, and you can solve for y. So what would that look like? So if we took the equation and we put x is 6 in it, okay. So do you see I wrote the same equation, I just replaced the x with the 6. Then rearrange it, just like a linear equation that we did before, and solve for y. So this would be 12 minus 3y equals 6. And we get the other that we knew was the right answer. So doing that, what would be an easy number to plug in if we wanted another x value? What about 0? Say I plugged in x equals 0, so I get 2 times 0 minus 3y equals 6. 2 times 0? Negative 2? So that will also work. And I could finish the rest of the course again by doing this, but it's a little bit harder. You can't just do it in your head. You might have to write it down and rearrange it and solve. Does that make sense? But all linear equations have infinite points. Actually, any equation has infinite number of solutions. There's sometimes restrictions. You can't plug in a negative, or you can't plug in a 0 on the bottom of a fraction. But really, with linear equations, there's no restrictions. So a linear equation has no restrictions. That means what? Okay. Now, TVs aren't like this anymore, but does anyone ever see an old TV that you can see the little squares? If you look really close to the TV, you can see the little squares all along the grid? And or you see those pictures, sometimes they'll make like a big mural, and if you go close, it's individual pictures of people or something, and all together it looks like something different. Do you know what I'm talking about? It's like little pixels. That's what these points are on an equation. So when we draw a line, we'll go back to our first easy one, x plus y equals 4. And let's just write down 2 points. Let's say 0, 4, and 4, 0. These are called the intercepts. Okay, so let's make a little coordinate axis, an x and y axis. So here's the x, here's the y. And how do we plot a point? We say this is x and this is y, so you go to 0 on the x, it means don't go left or right, and up 4. So this is the point, 0, 4. It is on the y-axis, so this point is called the y-intercept. It's where it crosses the y-axis. And the other point is 4 for the x and 0 on the y. This point is called the y, or the x-intercept. Okay, so. And then if we took some more points that work, say 1, 3, and 3, 1. Let's add those to the graph. So 1, 3, and 1, 2, 3, 1. What about 2, 2? 2, 2. What about 5, negative 1? So 5 on the x, 1, 2, 3, 4, 5, and down 1. Now, these points, what we do is just connect them, and that makes the line, which is the equation. In this class, it's all real numbers, so you don't ever leave as dots. So we connect this. But what this line is is just like those TVs or those pictures, that if you look really, really close to it, all it is a whole bunch of dots. Because is there dots in between these two? Yeah, those are the decimals. Like instead of, we could plug in 2.1, and what would add to give 4? 1.9. So 2.1 and 1.9. But we could actually go in between that too. We could say 2.05. And this would be 1.95. And I could get smaller and smaller. And each point, once you draw all of the points on, it now looks like a line. And that's how TVs used to work. They put enough points on there that it looks like a line. So you see the shape. But if you got really, really close, you could see the individual dots. Okay, and that's all any equation is, and any graphing is a whole bunch of points. And because you need so many points and the points in between, that it looks like a line. Okay, so that's one thing. How many points do we need to draw a straight line or linear equation? How many points? 2. And in fact, where you're doing it by hand, you're probably not using graph paper. I would suggest you not draw more than 2, because then if they don't lie in a straight line, just because your numbers or your tick marks are slightly spaced out different. So if you're not using a ruler, which I'm not, you don't have to do here, because what we want to do actually is learn how to draw them quickly, but accurately. So they go through the right points on the X and Y axis, and they have the right shape. Because what you're going to do in calculus is you're going to take something like this, and you're going to be asked to rotate it around the Y-axis, for example. And what then that looks like will be sort of like a funnel, and you have to actually picture that. If you're using graph paper and trying to get all the points right and concentrating too much on that, you're never going to get to the rest of the question. So you need to be able to take a graph, draw it in the right place, so that when you rotate it, you can see the shape that there is. Don't worry if you don't see it. They'll teach you how to do that. And then we actually are going to find, say, the volume or the surface area of this shape, using the graph of the original one. So you need to be able to quickly graph the original ones. They're not going to show you how to graph them, so that you can then rotate them and do other things with them. Okay, so that's the application of these things. So how many points do we need to draw a linear equation? I'm going to put a straight line here because this always comes up. A linear equation is a straight line. If the line's not straight, it's a curve. So a parabola would be a curve, or this one, which is a cubic, is a curve. It's not a straight line. Linear equation is a straight line. We need 2 points. You don't need more than 2 points. Usually the intercepts, because then you're crossing the graph in the right place. So usually the X and Y intercepts. All right, so let's get to it. That's what linear equations are. It's a series of dots. When you plot all the dots, it looks like a straight line. You don't need to plot all the dots. You just need to connect them, put arrows on the end, and you've got the linear equation. Okay, so what else is there about linear equations? There is also something called slope. So what's the slope of a line? Slope is another word for rise over run. That's kind of mathy. So more not mathy. What's it mean? If you were telling a little kid, you would not say it's rise over run. What could you explain it as? It's the steepness of a line? How steep a line is? Okay, and maybe you don't really think about it that way, but let's just draw a little ski slope. Here's my little ski slope. Here, hospital. Okay. So the ski slope's not a very good ski slope because it only has snow on top. Very dangerous, treacherous, it's just smooth, like glass with a little snow on top. So, anyone ever ski? Did you ever try to climb up the hill because you lost your pole up the hill? Up a steep hill? Not maybe this steep, but that's hard, right? Do you get good exercise doing that, climbing back up the hill? Yes. Let's call that positive. It's not a positive experience, but it's a lot of good exercise, climbing up a hill, okay? So if you're a little guy going up the hill, up here, we're going to say that's positive. Now, I'm going somewhere with this. Now, coming down on this particular ski hill is a very negative experience because, again, there's only snow at the top and the rest of it's like glass. Nowhere to dig your skis in, so you have to go straight down, that's it, and plunk at the bottom. There you are with your head popped off. Okay. This is to make you remember something, okay? So we'll get there. Now, you pick up your head and you get to the hospital that happens to be right there, but the door's on the other side. You can't get there because, you're not smart anymore. And you shouldn't have gone on the hill in this first place. So you try to go over the building. Is that possible? Only if which obviously you're not Spider-Man because you wouldn't be doing this. So you try to go up, which is not possible. All right. You guys are good. This is how you can explain slope. Okay. So here's slope. If on a graph the line is, we read from left to right, and if the line goes up from left to right, that's a positive slope. How can I make it harder to climb up the hill or more exercise? What can I do to the steepness of that hill? Make it steeper, which in slope words is a bigger number. So the bigger the number, the steeper the hill. Okay, so let's say, for example, we go right in the middle. This would be a slope of 1. Okay, the rise and the run, which you told me, are equal. Say the rise is 1 and the run is 1, it's equal, sits right in the center, okay? If we wanted a steeper hill, maybe that's 2, okay? Now what about a not as steep hill? What do you think? Right, half. So it goes down, less steep, less exercise, positive or higher number. But all of these lines are positive slope because they all are going up from left to right. Okay, so those are all positive slopes. Now the negative slope coming down, so here's a negative slope going down, same idea. So if we drew a few lines here, so negative, right in the center, whoops, you can do yours better than me, is -1. And then steeper would look like that. So this one would be, what would be an example? -2, and then not as steep, like a fraction, -1/2, or -1/3, or negative, right, and so on. Okay, so what about this one? Why do you think I said his head popped off? Any ideas? No. Not no slope. 0. So that's the head on the ground is the 0. Okay, now this one, a vertical line, has no slope. And that's why I say it's not possible to go up. You can't climb up, so the line that goes up over the building is no slope, undefined. Down at the bottom, where your head is laying on the ground, that's the 0. Okay, don't get the two mixed up. So it is not infinity, okay? That's not right. It's undefined. Some people say it's right infinity, which I think came from something they were told, but it's not right.
So that's due to the rise over run being there is no run, so you're flying like
Right, exactly. So, yeah, so going back to the more mathematical rise over run, what does this mean? The rise is up and down, that's the change in y. And change in x. Okay, so looking at this line, it's a positive slope because it goes up. The rise, when you go to one point and find any other point on the graph, it doesn't matter, find 2 points on the graph because a line is defined, you need 2 points to define a line, you don't need more. To find any 2 points on the graph that you know, so we know these 2 points. And the rise and run is how you get from one to the other. If these were lines you could walk on, and you had to walk up or down and to the left or right, okay? So if you're going from one to the other, let's go up first. So if we went up, how many steps do we have to go up, straight up? 2. So we'd have to go up 2. So the rise is up 2, which means plus 2. Now we're at this point. How do we get over to 3, 2 from there? We need to go how many? 1, 2, 3 to the right, 3, which is plus 3. So our slope, which we call m, is the rise 2 over 3, 2/3. So what does that mean about the steepness of it? Remember, 1 is right in the center, so this is not as steep as 1. Okay? Now, if we drew a negative line, okay? So I've got the intercepts on this line, and the line is negative. You go from one point to the other. So it doesn't matter which point you start at, but if you go to up, that's positive, and to the right is positive. So here, say we start here, we're going to go up or down? Down this time. How many? We're at 2, so down 2. So that's minus 2 for the y values, because that's going up and down, that is the rise. And then we're now down here at 0, and we need to go 4 to the right, which will be plus 4, will be the run. So when we say this is rise over run, we get negative 2 over 4, which is negative 1/2. So not as steep as negative 1, right, because it's a fraction, and negative as it's going down. Now, what happens when we have a horizontal or vertical line? I'm going to give you this point. This is where people go very wrong. Okay, oh, sorry, I just did. Say it's 4, 0. Okay, right there. Tell me another point on that line. No. Yeah, so let's put this point, and where would it be? So we're 4 on the x and up, say 1. So this would be 4, 1. Give me another point on this line. Right here. Say 4, 2. What about down? Yeah, I don't have room for 4, 1, but let's say this is 4. That's that point. 4, negative 2. Does that make sense? What's happening with all the points on this line? The x value is all the same. The x value is the same on a vertical line. So on a vertical line, all points, what could we say, have the same, what? X value. The equation for any vertical line so the equation, remember we wrote equations, x plus y equals 4, or 2x minus 3y equals 6, like an equation, if it's missing one of the letters, so if it's just said x equals 4, the y value can change, but if this is saying x is always 4. It's still linear, the y can be anything. So 4, 0, 4, 1, 4, 2, 4, 3, 4, 100. Or 4, negative 10, 4, but the x value is always 4, and that's the equation. It just looks like that. That is not a point. It's not just one point. If you see x equals 4, it means all of the points where x is 4, which are all of these points together, which makes a line. Now the slope, if we pick 2 points, say 4, 1 and 4, 0, and if we wanted to do the rise, how do I get from one to the other? Up 1 or down 1, it doesn't matter. So say we go up 1 to get from 4, 0. So the rise would be plus 1 between those points. And then what's the run? We don't go to the left or right. We just go up 1, that's it. So the run would be 0. So the slope is rise over run, which is what? 1 over 0, which is undefined. Vertical lines have no slope. The slope is undefined. And a horizontal line, the equation is y equals a number. Whoops. Y equals a number. And the slope is 0, and that's because if we did rise over run, this time the rise will be 0, we don't go up or down, and the run can be whatever number, and that's okay, that's equal to 0. So the slope is 0. Horizontal line. Say 2 points on a horizontal line, or 3. We're always up 1. So this particular equation would have, the equation would be y equals 1. And rise, we don't go up or down to get to another point, so rise is 0. Run is whatever 2 points you pick. So if we said between here and here, the run would be 2. It doesn't matter because 0 over whatever number is 0. Okay. Now, I said something earlier that you probably didn't even register what I said, but sometimes a question will say, what is the straight line through these 2 points? These are straight. You could draw them with a ruler. These are straight lines, horizontal, vertical lines, but so is this. Okay, all linear equations are straight lines. Okay? What happens, I think, sometimes you're thinking a straight line and people somehow think it's talking about a horizontal line only. Okay, for some reason. So don't get stuck in that thought and then do the question wrong when it says find the straight line through these points. That just means the equation of the line through those points. It could be any straight line, any linear equation. Okay? Okay, so when we have two equations together, a system of equations, now a system of equations can be two or more equations together. We're only going to do two. So say we take x plus y equals 4 and 2x plus 4y equals 6. Okay, so what they're looking for when you have more than one equation is the x and y value that actually works in both. Okay, so we want the solution to this is the point xy that works in both equations. Now the solution to just one single line, there's infinitely many solutions because every point on it is a solution. So each of these individually has infinitely many points on them, but together, how many points would work? You probably can't find it, although we could list a whole bunch of solutions for this one and then try them all in here and see which one works. But usually there's just one solution because you draw two lines and they cross at a point and that point's the solution. So here's what we're going to do. So part 1, graph both lines. Okay, so how do we graph a line? So you're going to take our first line, x plus y equals 4. So step 1, find the x and y intercepts, or any 2 points. Okay, so to find the x-intercept, we're going to let y equal 0 because the x-intercept's on the x-axis, so we don't go up or down to get to that point, so y equals 0. So we just plug that in. If y is 0, then we put a y as 0 in here and we get x equals 4. So our x-intercept is x equals 4 and y is 0, so that's that point. Our y-intercept, we're going to let x equal 0. Same equation, 0 plus y equals 4. Gives me y is 4. So that's a point, 0, 4. Okay, so we've got the x and y intercepts for our first line. We want to graph that one and the other one on the same. So here's line A, and B is 2x plus 4y equals 6. So we do the same thing. So we're going to find the x and y intercepts for that. You really need to be able to find the x and y intercepts so quick without actually writing it down. Other points you can write down, but the x and y intercept, you really need to be able to do those in your head, okay? To be successful in anything, you do this so often, you need to be able to write them down. So I'm going to show you how to do that. So let y equal 0. So if we plug y as 0 in here, what do we get? 4 times 0? which is 0. Divide by 2, so we get x is 3. Okay, now I said you have to do this in your head, not writing it out like that. So how do we do it? If you're plugging in 0, what happens to that term that you plugged in 0 for? It disappears. Do you see it's gone? So this is what I tell people to do. You've got your equation, you need your x-intercept. So cover up the y. Okay? So what do you have left? 2x equals 6. How do we solve for x? Divide both sides by 2 and you get 3. Okay? You could even write down that equation, 2x equals 6, without having to write the 0 in. So let's do that here. For y-intercept, we're going to let x equal 0. So our equation is 2x plus 4y equals 6. So what you're doing is saying, okay, the x has to be 0, so cover up the x or scratch it out. And we've got this new equation. So what's the y-intercept? Y equals 6 over 4, which is 3 over 2. Because that 0 will make that term disappear. Does that make sense? Plugging in 0 is easy. Okay, so we've got our points. Oh, we forgot to write the point for this one. 3, 0. All right, and then you're going to draw an x and y axis. Look at your points. We've got a 4 for the x and positive numbers, so we need a big positive axis here. Here's your x and here's your y. So for line A, 4, 0. 1, 2, 3, 4. Write your point in. 1, 2, 3, 4. That's this one. And connect them. If you've got a ruler or a straight edge, that's better, especially when you're doing 2 on the same graph. And then label it. So x plus y equals 4 was that line. Okay, why label it? When you go back and need to do something with the line, you can quickly figure out which one is which because you've labeled them. Okay, that happens. And then our second line are these 2 points. So 3, 0. Oh, let's do a different color. And 3 over 2 is what? 1.5. 2 goes into 3 once, with 1 left over, right? 1.5, so 1, 2, 1.5 is in here. Oops. A ruler would have been better. There we go. And this one is 2x plus 4y equals 6. Okay, so there's our 2 lines. How many places do they cross? 1, right here. Now, did anyone draw this really nice and neat and can take a guess at what point that might be? I made it so it works out nice. So what's everyone's guess? We're going to learn how to solve it next class, but yeah, what do you think? So here's the x, maybe 5, -1. Now if we had graph paper and rulers and you put your points exactly, it would probably fall just about. If you did it on a calculator, it would fall right in the right spot. By hand, without rulers, maybe your tick marks are not evenly spaced. That might not be it. How would we know if that's it? So this I just did by guessing. We're going to learn how to do it next class without guessing. How do we know if that's the solution to this system, the point that works in both? Well, plug it both into both of them and see if it works. So, so you could check. So x plus y equals 4, does it work in that one? 5 minus 1 is 4, yep. And our second line, 2x plus 4y equals 6. So 2 times x, 2 times 5, plus 4 times -1. So that would be 10 minus 4 is 6. True? Yeah. So our solution, our guess, is the actual solution. Now, we'll learn how to find the solution without graphing it, because most of the time I'm not gonna say graph it and look at the graph to find the solution. You're gonna actually find the solution and then use that to graph, so that you make sure they cross in the right place. Okay, so next class, we'll continue with this.